హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు ఈ ఫ్రీ ఆన్లైన్ క్లాసెస్. మనం లాస్ట్ క్లాస్లో ఫ్లూయిడ్ మెకానిక్స్కి సంబంధించి ఫ్లో ఆఫ్ ఫ్లూయిడ్స్ పార్ట్ 1 దట్ ఈస్ ఫ్లూయిడ్ కైనమాటిక్స్ అనే టాపిక్ని చూసాం. ఈరోజు క్లాస్లో ఫ్లో ఆఫ్ ఫ్లూయిడ్స్ పార్ట్ 2 దట్ ఈస్ ఫ్లూయిడ్ డైనమిక్స్ అనే టాపిక్ని చూద్దాం. ఎవరైనా మా ప్రీవియస్ వీడియోస్ చూడనట్లయితే లింక్ డిస్క్రిప్షన్లో ఉంది, వెళ్ళి చూసేయండి. ఫ్లూయిడ్ డైనమిక్స్ క్రింద ఉన్న సిలబస్ ఏంటంటే energies in fluid motion in that datum head, pressure head and velocity head, total energy of a fluid in motion that is Bernoulli's theorem, practical applications of Bernoulli's theorem in that PITOT tube, VENTURIMETER and ORIFICE meter. First, what is meant by fluid dynamics? It is the study of fluid motion with the forces causing flow. In another way of defining is, it is the study of fluid in motion considering the pressure forces. The dynamic behavior of a fluid flow is analyzed by Newton's second law of motion, that is F is equals to ma, which relates the acceleration with the forces. The fluid is assumed to be incompressible and inviscous. Incompressible means the density is constant. And the non-viscous means the viscosity is zero, that means frictionless. Next, the total energy of a fluid in motion, that is Bernoulli's theorem. The statement of Bernoulli's theorem is, it states that in a steady ideal flow of an incompressible fluid, the total energy at any point of the fluid is constant. The total energy at any point is constant. The total energy consists of pressure head, kinetic head and potential head or datum head. First we see what is meant by steady ideal flow. Steady flow means the flow characteristics such as velocity, pressure and density with respect to time at any point are not changing. In mathematically we write dou v by dou t at a point x, y, z equals to 0. This is called steady flow. Ideal flow refers to viscosity is 0, that is frictionless. Incompressible fluid means the density is constant. Statement of Bernoulli's theorem చూసాం. ఇప్పుడు అజంప్షన్స్. బెర్నౌల్లీస్ ఈక్వేషన్ డిరైవ్ చేసేటప్పుడు సమ్ అజంప్షన్స్ అనేటివి చేయడం జరిగింది. అవి ఒక 4 ఉన్నాయి. దాంట్లో మొదటిది వచ్చి ద ఫ్లూయిడ్ ఈజ్ ఐడియల్, దట్ ఈస్ విస్కాసిటీ ఈజ్ 0. ఇట్ రెఫర్స్ టు frictionless. The flow is steady, that is the flow characteristics, that is velocity, pressure, density etc. with respect to time at any point doesn't change. Incompressible, the flow is incompressible, that means the density is constant. The flow is irrotational, that means the fluid particle does not rotate about its own axis. It follows the streamlines. The flow is in streamlines only, but it does not rotate about its own axis. That is called irrotational flow. These are the 4 assumptions made in Bernoulli's theorem or Bernoulli's equation. Next, Bernoulli's theorem, how we can derive this? From the Euler's equation of motion. We can derive the Bernoulli's equation from Euler's equation. The Euler's equation is dp by rho plus G dz plus V dV is equals to 0. This is the Bernoulli's equation. If you need a detailed derivation of Euler's equation, please refer R.K. Bansal textbook. Otherwise, in the last we provide material. Please refer it also. If you understand Euler's equation of motion detailedly. And Bernoulli's equation is obtained from the Euler's law is by integrating the Euler's equation. By integrating dp by rho, we get p by rho plus g dz gz plus v dv, that is v square by 2. ఓకే, నేను సింప్లిఫై చేయడం కోసం నేనేం చేశానంటే జీని అన్నిటితో డివైడ్ చేశాను. సో పీ బై రో జీ ప్లస్ జెడ్ ప్లస్ వి స్క్వయర్ బై 2g. దిస్ ఈజ్ ది ఫార్ములా ఫర్ Bernoulli's equation. This is the equation of Bernoulli's equation. That is p by rho g plus z plus v square by 2g is equals to constant is the Bernoulli's equation. P by rho g plus z is called as piezometric head. It is called as piezometric head. Next, energies in fluid motion. Bernoulli's equation of motion is given by, from the last slide we see p by rho g plus z plus v square by 2z is equals to constant. This is the Bernoulli's equation of motion. P by rho g is called as pressure energy per unit weight of the fluid or pressure head. Z is called as potential energy per unit weight or potential head or datum head. V square by 2g is called as kinetic energy per unit weight or kinetic head or velocity head. These are all energies only. Okay, so the Bernoulli's equation is based on the conservation of energy. The point is noted is it is based on the conservation of energy. ఏది బెర్నౌల్లీస్ ఈక్వేషన్ అనేది కన్జర్వేషన్ ఆఫ్ ఎనర్జీ మీద బేస్ అయి ఉంటుంది. వాట్ ఇట్ సేస్, కన్జర్వేషన్ ఆఫ్ ఎనర్జీ సేస్ energy neither be created nor be destroyed. Energy neither be created nor be destroyed. This is the conservation of energy. Next one is Bernoulli's equation for real fluid. The Bernoulli's equation was derived on the assumption that fluid is inviscous, that is non-viscous. Frictional less అనుకొని మనం Bernoulli's equation చేసాం. But in real fluids the viscosity is present, right? Viscosity is present for the real fluids and hence they offer resistance to flow. There are some losses in fluid flow, hence in the application of Bernoulli's equation these all losses have to taken into consideration. Okay, for the real fluids the Bernoulli's equation for 2 points is changing like this. For the first point, p1 by rho g plus v1 square by 2g plus z1 is the at the first point. This is, let's say this is a flow. I consider this is first one point, this is second point. For the first point the total energy is p1 by rho g plus v1 square by 2g plus z1. And the second point p2 by rho g plus v1 square by 2g plus z2. HL for the real fluid, it is the loss of energy between the point 1 to point 2, loss of head. Next one is practical applications of Bernoulli's equation. The Bernoulli's equation is applied in all problems of incompressible fluid flow. If the flow is incompressible, the Bernoulli's equation is applicable. There are three measuring devices, namely Venturimeter, ORIFICE meter, PITOT tube are the practical applications of Bernoulli's equation. These are based on the Bernoulli's equation. They work based on the Bernoulli's equation. Okay, Venturimeter and ORIFICE meter are used to measure the rate of flow, that is discharge, and in the PITOT tube is used to measure the velocity. Next one is the Venturimeter. Venturimeter is a device used for measuring the rate of flow, that is the density, the rate of flow, that is discharge. It consists of three parts: a short converging part, throat, and diverging part. This is converging part, this is diverging part, this is throat. This is called as inlet, this is called as outlet, this is called as throat. It is based on the principle of Bernoulli's equation. The next one is Venturimeter. We don't need any derivations, but we need only the formula for the problems. We remember this formula. Based on the Bernoulli's theorem only, these rate of flow equations are derived. If you have any doubt, please refer R.K. Bansal textbook. Rate of flow through Venturimeter. This is the Venturimeter. Q is equals to A1 A2 by square root of A1 square minus A2 square into under root 2GH. It is the rate of flow. This is a theoretical one. If you calculate actual, you multiply the theoretical rate of flow with the coefficient of discharge. Coefficient of discharge. If you calculate the real fluids, we calculate head loss, right? The head loss is equals to, for the Venturimeter, 1 minus CD square into H. This is the formula for head loss for Venturimeter. The coefficient of Venturimeter, its value is less than 1. It is less than 1. The next, the value of H. This is the H value, right? For determining H value, we have 4 ways. By using differential U-tube manometer. Let the differential manometer contain the liquid which is heavier than the flowing liquid. That is, manometric fluid is heavier than the flowing liquid. Then the H value is determined. H is equals to X into specific gravity of heavier fluid by specific gravity of flowing fluid minus 1. This is the formula to determine the H value in case of the manometric fluid is more than the flowing fluid, the density. Okay, SH is a specific gravity of a heavier liquid, S0 is specific gravity of the flowing liquid, H is the difference of heavier liquid column in U-tube. Okay, the next case is if the differential manometer contains the liquid which is lighter than the liquid flowing through the pipe. That is, the manometric fluid, the density of the manometric fluid is less than the flowing fluid. Then the formula of H is given by H is equals to X into 1 minus SL minus S0. SL refers to, this is called the specific gravity of manometric fluid, that is lighter liquid. S0 is flowing fluid. If the Venturimeter, the first two cases for horizontal Venturimeter, that is, the Venturimeter is, this is the Venturimeter. Let's say this is the Venturimeter in the first two cases. That is, this is a throat, this is a converging, it is a diverging part. Horizontal one for the first two cases. If The venturimeter is inclined. Inclined, what is the formula? Inclined, what is the formula? Sorry, the figure is not up to scale. This is a rough sketch only for your understanding. This is inclined one. How the H value is determined? By using the specific gravities and by using the pressure head and by using the heads also. This is the first point, this is the second point. Okay, inclined. So at the first point we calculate datum head and the pressure head, minus in the second point you calculate the H value. This is the first method. In the second case we calculate the heavier liquid case also, x into SH by S0 minus 1. This is the another formula to calculate H value in the inclined venturimeter. If the manometric fluid, the density of manometric fluid is heavier than the flowing fluid. In the next case, the manometric fluid is less than the flowing fluid in case of inclined venturimeter. Okay, based on the heads also we can find, and based on the specific gravities also we can find the H value. This is the formula: P1 by rho g plus Z1 minus P2 by rho g plus Z2, that is equals to, this is x into 1 minus SL by S0. This is the specific gravity of manometric fluid, that is lighter. S0 is flowing fluid. I hope up to this point clear. The next one is orifice meter or orifice plate. It is also used to measure the rate of flow, that is discharge only, Q value only, of a fluid through a pipe. It is cheaper device as compared to the venturimeter. Why? Because venturimeter, it is pipe. This is one, it's one, this is throat, and this is a diverging pipe. This is the heavy arrangement of venturimeter, more arrangement. But in case of orifice meter, just we put an orifice plate, that is, this is a pipe flow, this is a pipe flow. I put orifice plate here. I put orifice plate here. That means it is, the flow is like converged from here. It is just a plate, it's not a heavy arrangement, so it is very cheaper than venturimeter. It also works on the same principle. It's also same principle of Bernoulli's theorem only. Same principle. It consists of flat circular plate which has a circular sharp edged hole called orifice, which is concentric with the pipe. That is, concentric means inside పైప్కి లోపల ఉంటుంది అని చెప్పేదాన్ని కాన్సెంట్రిక్ అనేది అని చెప్తాం. The orifice diameter kept generally 0.5 times diameter of the pipe. Generally varies 0.4 to 0.8 times of the pipe diameter. Generally it is varies a dia of orifice, right? DO is equals to 0.4 to 0.8 times of a diameter of the pipe. Generally we adopt 0.5 times of diameter of the pipe. This is orifice meter. Let's say this is the figure of orifice meter. This is the figure of orifice meter. This is the direction of the flow. This is the orifice meter. If you measure H value, you put differential manometer. The discharge equation will be Q is equals to A naught Cc under root 2GH. Why? Because here the flow is contracted, so we consider coefficient of contraction Cc value. What is meant by Cc? We can study in the next chapter, next topic. This is the general formula, but Cc is not known for me. We get a relationship of CD and Cc and put the Cc value in the above equation. We get Q as CD into A naught A1 under root 2GH by under root A1 square by A naught square. This is the discharge equation for orifice meter. CD is coefficient of discharge for orifice meter. The coefficient of discharge for orifice meter is much smaller than that of venturimeter. Venturimeter is less than 1. The discharge coefficient CD value for the orifice meter is very less than the venturimeter. The next one is pitot tube. It is mainly used for the measuring velocity of the flow at any point. It is based on the principle that if the velocity of the flow at a point becomes 0, at a point the velocity of the flow is 0, the pressure there is increased due to conversion of kinetic energy into pressure energy. Okay, this is the principle behind the pitot tube. In its simple form, the pitot tube consists of glass tube bent at 90 right angles, that is 90 degrees with the horizontal. The theoretical velocity will be root 2gh. The actual velocity will be Cv into root 2gh. Cv value is coefficient of pitot tube. Actually, the Cv is coefficient of velocity. Okay, we don't need any derivations. Just we remember the formula to solve the problems. That's enough. If you need, please text me. I make a document on the derivations also. The next one is pitot tube. Velocity of flow in a pipe by pitot tube. It have 4 cases to find the velocity at any point in a pipe by using pitot tube. The first case is pitot tube along with vertical piezometer. This is the first case. Pitot tube, a vertical piezometer. This is the first case. The second one is pitot tube connected with piezometer tube. This is pitot tube connected with piezometer tube. And finally, we determine the velocity. We find the velocity of the flow. The third case is pitot tube and vertical piezometer tube connected with a differential U-tube manometer. This is the third case. This is a pitot tube U-tube manometer. You can connect this. For the U-tube manometer, you calculate the H value. And the third case is a pitot static tube, which consists of 2 circular concentric tubes, one inside the another. This is one and this is another, with some annual space in between. The outlet of these 2 tubes are connected to a differential manometer. This tube and this tube is connected to a differential manometer, where the difference of pressure head is H is measured by knowing the difference of the levels of the manometer liquid, say X. We use the same formula for determining H value. I hope this class is helpful for you. Please like the session. If you like the session, please share to your friends. In the next class, we see an amazing topic. Thank you.